Welcome to part 3 of the video on trigonometric integrals. In this video we're going to consider the third case of the four cases that we presented in part 1. This fourth case is when you have in your integral you have the functions tangent of x and or secant of x. And as an example we're going to find the integral of tangent cubed of x dx. And the idea here is to use this identity, tangent squared of x equals secant squared of x minus 1. Always the idea is to use this identity when you have tangent of x and secant of x. So in this case you can write this, as you have an odd power here, we can write this as tangent squared of x times tangent of x. We write this like this because in this form we can replace here tangent squared of x by the right side of this equation. So we do that, and we replace tangent squared of x by secant squared of x minus 1, and we have that times tangent of x dx. Now we can distribute this product, and we have the integral of secant squared of x times tangent of x dx minus the integral of tangent of x dx. And let's write tangent of x in the second integral as sine of x over cosine of x. We do that because we're going to solve these two integrals using substitution. Both of these integrals can be solved using substitution. In the first integral we're going to substitute, we're going to use the variable u that will equal tangent of x. So du over dx equals secant squared of x. That's the derivative of tangent of x. On the second integral we're going to use the variable v that will equal cosine of x. So that dv over dx equals minus sine of x. So we replace these variables in our integrals. In the first integral we have u that equals tangent of x times du over dx, that's secant squared of x times dx. In the second integral we have 1 over v, because v equals cosine of x, times sine of x that we can write as minus dv over dx times dx. Here we can cancel the x, here we can cancel the x also. So this becomes the integral of u du, and here we have a minus times minus, that's plus the integral of dv over v. So these are two very simple integrals. We know how to solve this. The first one is u squared over 2, and the second one is the natural log of v plus c. Now we only need to substitute back our variables u and v. So we know that u equals tangent of x and v is cosine of x. So simply replacing, we get the final answer for our integral. That will be tangent squared of x over 2 plus the natural log of v, that's the natural log of cosine of x, plus c. That's the final answer. So when you have any integral with tangent of x and secant of x, the idea is the same as the one we used in this example. You try to use the identity that relates tangent of x to secant of x, and then you use the fact that the derivative of tangent of x is secant squared of x, and use any other trig identity you know, and any other method you know for solving integrals, for example substitution. So that's all for now. Thank you for watching and see you next time.